Hey everyone, Mike here from ArnoldTutoring.com with a great vectors question. We've got a three-way tug of war. Three ropes of equal length are tied together. Nikki pulls with one force, Jeanette with another, and Alan with another. And we've got to find the magnitude and direction of the resultant force on the knot. So we know the knot's just not going to stand still because there's three different forces from three different directions affecting it. If they were all equal forces with equal angles in between, then it would just stay in one spot. But because they're all different, it's going to move somewhere. I've drawn the diagram, and it's really important that we draw it a certain way. You can actually choose which axis you want one of the ropes to go along. I've chosen to put Nikki's, the red rope here, along the x-axis to the positive to start. That way it's kind of going in the same direction as the unit circle, which sort of starts out here at the positive x-axis and then rotates counterclockwise. This is definitely a vectors question where we have to include both the x component and the y component. So I'm going to start with Nikki's x component, and we can see that's just 210 newtons to the positive, right? It's just this red rope. Nikki's y component of her vector is 0 newtons. Now that's the way I've drawn it. They didn't really specify which direction in terms of north, south, east, or west, so I've just used that axis for simplicity, and then I've drawn the other two with the prescribed angles that the question says. So there's 120 degrees between each one, so this is 120, 120, and 120. So I've tried to make those look semi-equal. Now we need to do the x and y component for the orange rope, which was 190 newtons, and that's what Jeanette is pulling with, so let's do that in orange. So her x component, well, again, this is why I started on the x-axis with Nikki's. If you rotate 120 from Nikki's, we know that's in quadrant 2. How do we find the x component of any spot on a unit circle? Well, we just do the hypotenuse, which is 190, times cosine of the angle from the starting point, and that angle is 120 degrees. So I'll say that again. We're rotating from the x-axis starting point all the way to our terminal arm. The x component of that vector is always cosine of the angle, right? Cosine of the angle, or cosine theta, is our x component, sine theta is our y component, and then we're just basically scaling it up by whatever that hypotenuse is, in this case 190. So same thing goes for her y component, is it's 190 times sine of 120. Again, this is where vectors can really be simplified down because they're actually just pre-calculus but applying to problems, right? We learned the unit circle well before we actually got into calculus and vectors. Let's do the same thing with the with Alan's rope, this green one here. So I shouldn't write n, that should be a sub x. So a sub x equals 200 is Alan's hypotenuse, because that's the force at which he's pulling the rope. And from the starting point, that angle is all the way around, so that's an angle of 240 degrees. So it's times cosine of 240. His y component is 200 times sine of 240, sorry. Let's calculate all of these. So I've used a calculator to find the x and y forces. So every vector in any direction has an x component and a y component. We have broken those all out. So now if we want the total x component on the resulting vector, I'm just going to add up all of my x's. So it's 210 minus 95 minus 100, and that equals a resulting positive 15 Newton force from an x component, so the horizontal force on it is 15 newtons. The total or resultant y component is going to be 0 from Nancy plus 164.5 from Jeanette plus negative 173.2 from Alan, and that is going to result in negative 8.7 newtons. So in this case, the resulting x component of the vector is positive 15 newtons. The y is negative 8.7. So as far as our direction, we are, I'll draw it here in blue, we are positive x, negative y, so we're down here. And we could even draw a little triangle. This is the resulting vector. Negative 8.7, that's the y. Positive 15, that is the x component. If we want the we're asked for the magnitude and direction of the resulting force. So we've got x and y separate. To get the magnitude of any particular vector point, we just take the square root of each component squared, so it's Pythagoras. So 15 squared plus negative 8.7 squared, and we get a resulting vector of 17.34 newtons. That's always going to be positive because it's just a distance or a magnitude. Remember, magnitude is in absolute values. So that's the magnitude of our resulting vector. How do we get the direction? Well, you can see I've drawn that triangle. It should be pretty straightforward. We just are looking for this angle right here. I'll call it theta. So we know, I'll write it over here in green. We know that tan theta equals opposite over adjacent, so that's negative 8.7 over 15. So theta is going to be negative 30 degrees. Or it's in quadrant 4, so you could do the trigonometry to get 330 degrees, but we're going to write negative 30 degrees. So the resulting force is this vector right here with a force of, or magnitude of 17.34 newtons at an angle 30 degrees east of Nikki's rope, or south in this case, but 30 degrees clockwise from Nikki's rope. Hopefully that gives you a good idea of how these vectors questions work. Break them down into x components and y components using our unit circle trigonometry. The magnitude of each force is the newtons by which it's being pulled. When we find magnitude of overall of a vector with x and y components, we use Pythagoras like we did here. So it's really combining your new knowledge of vectors with your old knowledge of trigonometry. Hopefully that was clear. You can always send us more questions to info@arnoldtutoring.com.